So what is this actually a circular motion? As the name itself suggests, circular motion, this is the movement of object in a circular path. So that is the circular motion. That is the movement of object in a circular path. You know, some of the typical definitions we discussed about in a linear motion will also be discussed in the circular motion as for the whole entire bit. So just have to pay attention and stay focused, and I'll be able to understand what is actually circular motion is about. But for the sake of interest in this video, we can have to discuss about actually the angular displacement and some sort of the conversion units in which the angular displacement can be expressed up to. So take note of that. So let's say we have the object and are moving in a circular path. Let's say this is this actually circle with that center. And let's say this is the line drawn from the circle of the center. In that case, can also said to be a reference line. And I say we have the object at a point A on the circumference of the circle. And the object moving from actually a point A, let's say up to this point, within the same circumference of the circle. Let's say this is the point B. So what is the angle swept at the center with respect to this actually reference line? So now the angle swept is said to be actually angle theta. Now in this case, this is said to be the angular displacement. And that which means as the object is moving from a point A to point B with respect to the center of the circle and with respect to the reference line, it means the angle in which the object has swept at the center is given as that of angle theta, which is the angular displacement. So that's the distance in terms of the angle, and it is measured in radians. You understand what is that? That's the basic measure of the angular displacement, and also be expressed in terms of also the degrees. You also see how we can be able to have that out. So let's consider the radius of a circle given as r, and let's say the distance in which the object moved from point A to point B along the circumference of the circle is given as s. So this is what we call the arc length. That's the distance traveled along the circumference of the circle. So what is the relationship that exists among the three parameters: the radius of the circle, angular displacement, as well as the arc length? So in that case, it means the angular displacement is said to be a directly proportion to the arc length in the inverse relation to the radius. So this is the formula for the angular displacement, or this is how the three parameters are related. So now, assuming that the object has now traveled from the point A and along the whole circumference of the circle up to the same point. So what is that one? Now you understand that the radius of the circle won't change. Now the arc length will be expressed in terms of the circumference of the circle. That will be given as 2 pi r divided by r, where this is the radius of a circle. So this and this will have to cancel, have it as 2 pi. Now in radian, so which means the angular displacement can also be given in radian measure using this relationship. So which means a one complete actually 10 is corresponding to having it as 2 pi. So 2 pi rad. So take note of that. So now from the fact that the object has completed the one actually 10, it means according to the principle behind the angle at the point, it means the object has rotated about 360 degrees. So in that case, it means the angular displacement also being given as, so which means, mind you, angular displacement is given as 2 pi, as we have seen, that is in rads, also being given as 360 degrees. And also, now since the object has completed the 110, it means there is also one revolution. So it means there is one revolution. So which means the angular displacement can be expressed in terms of rads, degrees, as well as the revolution. So bear that in mind. So in this case, the conversion factors will be in the sense that 2 pi rad is equal to 360 degrees. And of course, this is the same as 1 pi rad is the same as 180 degrees, as you can see. And also, 2 pi rad is equal to 1 left. And also, you should have to understand that 360 degrees is equal to 1 left. So these are some of the conversion factors you should have to understand in that case. So that's how the angular displacement is expressed in terms of the revolutions, in terms of the radian measures as well as the degree measures. Now, for instance, let's say we have, now this case, let's say we have 261 degrees. What is this in revolutions and also in radians? So we understand that 360 degrees is equal to 1 left. How about 261 degrees? We'll have it as LS. So hence we'll have 261 divided by 360 times 1 left. So what is that? So 261 divided by 360. And times 1 left, we'll have it as, now should be 0.725 left. How about that one in radian measure? So we understand that we have, should be 360 degrees is equal to 2 pi rad. So should be that. And how about 261 degrees? We'll have it as the length. Hence we'll have 261 divided by 360 times 2 pi rad. And which pi is given as 22/7. You can see. I understand you know what is that one. So now in this case we'll have it as, now 261 divided by 360. So it should be 360. And the times 2 pi. Now it should be 4.56. Let's say 557. Or actually large. So take note of that. And also at your own time try to have this as well. Let's say we have 1500 left revolutions, should be in radians as well as the degrees. And how about if we have 0.00 degrees? What is that in radians as well as the in revolutions? And how about if we have, let's say, should be 0.12 rad. What is this in degrees? And also in revolutions. So take note of that.